Hey everybody, Mrs. Bodechon here. So this is AKS Portfolio 8B. It says I can construct an explanation based on experimental evidence to support the claims presented in Newton's 3 laws of motion. So on your paper, it asks you first, state the laws. What are they, right? You can't do anything with them unless you know them. So here are all the laws, and we're going to go over one at a time, okay? So first, Newton's first law. An object at rest will remain at rest, and an object in motion will continue moving at a constant velocity unless acted upon by a net force. So I gave you an example here. A book on a table will not move unless something moves it, or a baseball thrown in space will travel at the same velocity until something else hits it. Okay, so that's really what it's trying to explain. Newton's second law of motion, acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So in other words, it's telling us about the equation F equals ma, or force times mass, or force equals mass times acceleration. The bigger the force, the more the object speeds up or slows down, and the object moves in the same direction as a force. So a really good example is a bowling ball is harder to throw than a tennis ball because of the mass, right? Bowling ball is much more massive, tennis ball not so massive at all, okay? And then the third one, Newton's third law, when an object exerts a force on a second object, the second object exerts a equal but opposite force on the first. An example of that is a hammer hits a nail, and the nail hits the hammer with equal and opposite force. So we're going to go through each law, okay? So the first law, it says explain how the soccer ball in the diagram relates to Newton's first law of motion before and after it's kicked. Be sure to include the word inertia because Newton's first law is known as the law of inertia, okay? And first, what is inertia? Inertia is the resistance for an object to change motion. Whether it's speed up, slow down, turn, it just doesn't want to change motion at all. That's what inertia is, okay? So Newton's first law, remember, an object at rest will remain at rest, an object in motion will remain in motion unless acted upon by an unbalanced force. Before the soccer ball is kicked, it's sitting there in the grass. It's just at rest, right? It's going to remain at rest, and it does until acted upon by an unbalanced force. An unbalanced force is somebody kicking it. If I kick it, I just created an unbalanced force on the soccer ball, and then what happens? Then it's in motion, and it will continue to be in motion until other factors, other forces act upon it. In this case, if I'm kicking it on grass, the friction from the grass will slow it down. If there's a big breeze of wind coming by in the opposite direction, perhaps that will also slow down the ball from rolling, right? So we have all these outside forces that are going to contribute to the motion of that soccer ball as well. Okay, Newton's second law. You're given a picture of Mario, which I love. So we have Yoshi and we have Bowser. It says if Bowser and Yoshi were racing against each other in Mario Kart, which character would take more force to accelerate and why? So in this case, we're looking at Newton's second law, right? Because that's all about force equals mass times acceleration. I can tell you guys I'm always Yoshi when I play Mario Kart because I know Yoshi doesn't have that much mass, right? Because it doesn't have that much mass, Yoshi accelerates really, really quickly, which means he goes fast really quickly. And that's awesome for me because if I get hit with a turtle shell, I can start up fast again and hopefully win the race. But when I play against like my dad, he's always Bowser, and Bowser is the opposite. Bowser is very massive. Because he's so massive, he takes a long time to accelerate. So when he starts off really, really slow, right? But because he has so much mass behind him, once he gets going, he has enough he has like enough momentum behind him to like plow the road. If he hits you, you go flying off the road in Mario Kart, right? So as long as Bowser doesn't get hit, he's pretty much going to win. So you have to hit him with a turtle shell or something along the way in order to win against Bowser, because he's definitely going to be going faster than everybody if he's not hurt along the way. Okay. Um, so basically, what it's saying is which one's going to take more force to accelerate. It's going to be Bowser because he has more mass. Because Yoshi is less massive, it will take him less force to actually accelerate, just because his mass is so tiny. Okay. And then 8B, for Newton's third law, we have a rocket ship going into outer space, right? It says, explain the action reaction relationship taking place as the rocket ship launches into space. So this is referring to Newton's third law, the action reaction. So remember Newton's third law. When one object exerts a force on the second object exerts an equal but opposite force on the first. So how does a rocket ship get into outer space in the first place? Well, it pumps all of these hot gases, which you guys see here, right, downward. And because the force is so great downward, it's equal and opposite going up. So yeah, the gases are going downward. So what happens to the rocket ship? It goes up. And I know this sounds crazy because it's like, well, I'm doing the opposite of what I really want to do. But I need you to think about everything in life, because everything in life that we do to get somewhere is pretty much opposite. Think about how a bird flies. It flaps its wings down, 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 right? The force is down in order for the bird to go up and to stay up. If you think about rowing a boat, right? If you row a boat and your force is going to be backwards, you're going to move forwards. So you have to do things in reverse order in order to move in the direction that you want to move in. Same is true for this rocket ship. Everything is equal but opposite, okay? So there we go. That is Newton's 3 laws. Let me know if you guys have any questions.